Are you clever enough to dispute April's time paradox? What is this paradox? It essentially states that the concept of time relativity, as proposed by Einstein, implies that time travel must also adhere to the principles of relativity. For instance, if you consider the effects of time dilation, it proposes that different regions of the universe experience varying speeds of time depending on the curvature of space caused by the velocity and mass of matter. Using this logic, we can infer that an area with significantly higher mass perceives time at a slower rate. If we were to imagine such a region, such as a galaxy massive enough to experience only 1 billion years while 14 billion years pass for us, an intriguing paradox arises. To simplify, let's convert the years by dividing them by 1 billion. This means our region has experienced 14 years, while the other galaxy has only experienced 1 year. If time travel were possible, and we traveled 1 year into the past, an interesting question arises. If both our region and the other galaxy, which experiences time at a slower rate, are part of the same universe and products of the Big Bang, what would happen to the other galaxy if we traveled backward 1 year? Would the other galaxy not yet exist? One of two scenarios must apply, but neither would ultimately suffice. Scenario 1. If time travel were not relative, then traveling 1 year backward would bring us to 13 years after the Big Bang, while the other galaxy, which has only experienced 1 year of creation, would not have even yet experienced the Big Bang. Clearly, this cannot be the case. Scenario 2. If time travel were relative, and we traveled back 1/14 of our lifespan, a year from our perspective, this would convert for the other galaxy as well, meaning it would only experience a trip backward amounting to 1/14 of its lifespan, or approximately 0.0714 years. Although this seems more logical, it is not without its issues. The very concept of relativity implies that this phenomenon is distinct and individual, depending on an object's speed and mass. Therefore, the idea that a universal conversion occurs, connecting each object's relative speed and mass, seems highly unlikely. Accepting this would mean believing that our speed and velocity affect the time of a galaxy across the universe, which contradicts the essence of relativity. According to Einstein's general theory of relativity, our motion affects only us. The idea of a universal conversion that applies to all objects and regions of the universe during speed variations of a single object is a bit nonsensical to consider. Neither scenario 1 nor 2 can apply without its contradictions. We must accept that the object traveling back holds no definitive connection to the rest of the universe in terms of time travel in either scenario. Even if traveling back in time were possible for an object, time travel would be relative. In other words, we would have to accept that time travel for one object doesn't translate to time travel for all other objects in the universe. Would this then be considered time travel? This very inquiry becomes paradoxical in nature. Without a unified connection among all objects, how can a trip backward in time apply to an entire relative universe? It simply cannot. Of course, time travel can be viewed in one of two ways. The first suggests returning both the object and the universe to a past state. The second implies, despite any evidence, that there are an infinite number of repeating instances. However, before we venture off point and jump down that rabbit hole of contradictions, please allow me to continue to my next point before you decide to embrace this difference as your basis for argument. Regardless, a dilemma still arises for each perspective. To better understand this concept, imagine if an object were to hypothetically travel faster than the speed of light. It is believed that time for this object would not just slow down, but actually start reversing. If it maintained this superluminal speed from our region of space and stopped in this other distant galaxy with much higher mass, what mathematical framework would explain how far back in time it traveled from each region's perspective? Which past would it arrive at for each region? If time has stopped for an object, as it would at light speed, we can infer that time for this object ceases while the rest of the universe continues to experience its relative time. Logically, this makes sense. However, if time were to reverse due to faster-than-light travel, math can no longer support it. If time begins reversing for an object, then which frame of reference would the object use? The relative time of our region of space, or that of a region with a slower rate of time? The very notion of this is contradictory. Because time does not function in this manner, the frame of reference for this hypothetical time travel could be either region, leading to two very different outcomes. This contradiction arises from the assumption that time travel is possible in a relativistic universe. In reality, because the universe experiences relative time, time travel is not feasible. If this example isn't challenging enough, consider the same scenario with the addition of an even more massive region in between. Imagine our faster-than-light object crossing a region of intense mass between our location and the other galaxy. Despite the object's consistent speed, many years would be added to its journey. How would its time travel be affected in this case? Once again, this scenario brings rise to incomprehensible issues because it does not align with the fundamental workings of the universe. This thought experiment merely attempts to impose a human construct on a universe that does not function in this manner. Time dilation, which is widely accepted in the field of physics, must therefore suggest that time travel cannot be possible. Relativity, at its very essence, insists that time travel is impossible. It is more logical to deduce that these paradoxes arise in each scenario, because time travel is more of a human construct than an actual phenomenon in the universe. The reality is that math cannot support it. Therefore, a successful theory must include why time travel cannot exist to fully explain the essence of time dilation. Fortunately, there is an elegantly acceptable explanation that both defines time and explains why time travel is impossible.